All right, welcome back in. We are continuing on with the Integumentary system, Chapter 5 of OpenStax, and we've talked about the layers of the skin, the epidermis, dermis, and hypodermis, and some of the accessory structures you find within. Talked about hair follicles, sebaceous glands, sudoriferous glands, nails, and so on and so forth. We are now going to talk about Section 5.3, the functions of the Integumentary system. And although I am quite certain you've also learned how this works, I thought just in case you haven't played around with it enough, I would also show you a little bit about how the OpenStax textbook works for your studying purposes. So, when it comes to the functions of the integumentary system, we're going to see four things. We're going to see that the integumentary system provides protection, it provides for sensory function, it provides for thermoregulation, and also provides for the synthesis of vitamin D. And I'm going to come back to that in a minute. But I wanted to show you that if you were studying this chapter and you said, okay, well, it looks like I need to remember that the integumentary system provides protections, you could highlight that and then say, well, let me remind myself. So I'm going to include this here. You could also include a note if you wanted to, like study this for the exam, or whatever you might want to include in your textbook. Maybe something you heard in one of my videos or Travis's videos, or something that links pieces together for you. Anything. So here I've just included this, and if I want to get rid of it later, I can just delete the comment, or I can edit the comment. In any event, if I go here and I say, well, let's see, I want to remember this is protection. I want to make sure I take a look at that. So now I've got it highlighted, and then I notice here it says the skin protects the rest of the body from basic elements of nature, such as wind, water, and UV sunlight. Oh, well, might want to remember that. So what does it protect from? It protects from wind, water, and UV sunlight. So I can just highlight that for myself to remember. It's a protective barrier against water loss. Okay, well, maybe I want to remember that as well. And then it looks like it also does something else. So it says it also is the first line of defense against abrasive activity due to contact with grit or a scratch. Also protects against microbes or harmful chemicals. So I might just want to say, well, it looks like I would want to remember those three pieces. It's a first line of defense against these three things: harmful chemicals, possibly bacteria, and some sort of microbe, and also the minor abrasions. And here it also says that the sweat glands are producing some things that might also be important to providing protection, including this dermicidin, which is a kind of small protein that can be used to kill bacteria. So I may want to remember that one as well. So I might want that one to stand out. Use purple there. Okay, in any event, you see what I'm saying. So this is a nice way to highlight the things you're studying and know when you come back. When you go out of this and come back to it in your version, it'll be saved just like you left it. So it never leaves. Those annotations never leave. Let's come down to the Sentry function for a moment. So we've gone over the fact that integument does protection, but it also provides an important sensory function for our bodies. The skin, of course, is the part of your body that faces the outside world, and for that reason, it's collecting all kinds of information about the outside world, including temperature, including things that might be coming in contact with you that you need to know about. It's important that you would need to know that, for example, you have placed your hand on something that is very hot. So before you have a very, very bad damage, you'd be able to pull your hand away or move in a way that would protect you. Also, just coming into contact with things like leaves or something that you might not know that you're coming in contact with would give you an idea of, well, I might have been touching poison ivy or whatever, or just touching anything as you move around in your environment. There are a couple of important pieces. We talked a little bit about Meissner's corpuscles before. These are those little tactile corpuscles that are found living right in these projections of the dermis up into the epidermis, called the dermal papilla. And so there's a Meissner's corpuscle, and it is one that responds to very, very light touch. And these are specifically really, really well distributed in areas that you have thin skin and where you can feel very, very light touch, like the back of your hands, for example, are filled with Meissner corpuscles. If you'd like to see how they work, take one of your hands and just barely touch the surface of your the back surface of your other hand, so that it's almost not touching, but you're just barely touching, and you will sense that, and that's entirely because of those Meissner corpuscles. Deeper into your dermis, you will find larger corpuscles called Pacinian corpuscles. Here they are, the Pacinian corpuscles. I'll just highlight that for you. Let's remember that, Pacinian corpuscle. And these are much deeper in the dermis, and they provide a response, or they provide sensitization to vibration. So if you're pressing a little deeper on your skin, or you place a finger on the back of your skin and move it back and forth, the Pacinian corpuscles are the ones that are alerting your brain to the fact that, hey, there's something pressing on my skin a little bit more deeply than the Meissner corpuscles have been picking up. The Meissners are overrode when you're pressing down hard, and the Pacinian corpuscles take over and send that information to the brain. We'd already seen about Merkel cells. These are also picking up light touch, so they're distributed across the skin in different places as well. And then, there's just a number of other nerve endings, sensory nerve endings that are found in your epidermis and in your dermis that can sense pain, can sense temperature, etc. So very important about this. They also, these nerves, as you see here, motor neurons, these are the kind of nerves that cause a muscle to contract. Motor nerves are innervating the erector pili muscles. And also sebaceous and sudoriferous glands, and so they are responsible for activating those structures, the erector pili muscle, to cause the hair to stand up, and you get goosebumps, right? We talked about that. That is because a motor neuron has sent a message out to that to contract and do that, or the sebaceous gland to release their products into the hair follicle, etc. So important to remember that. Okay, so that is the function of sensory, right? And then we're going to go on to thermoregulation. And honestly, I'm not going to spend a whole lot of time here. As you recall, the thermoregulatory system in the body is largely cared for at the skin, at the integument. And there's a couple of things. We talked about the fact that, if it's very, very hot, what happens is you'll get these arterioles and venules to open up and let a lot more blood flow into the skin, so as to distribute the heat from in the body to the outside. And when it gets really cold outside, you close those off and you really shunt the blood away from the skin surface, keeping the warm nature of the blood protected from the external. So this is one thermoregulatory mechanism. But remember, the sudoriferous glands, the eccrine and apocrine glands, are also very important because they're producing the sweat, which the perspiration, which when it gets onto your skin or into your hair, allows for evaporative cooling, which also helps to bring the temperature of the body down. So you'll sweat if you get overheated, and you won't sweat if you're getting too cold. So anyway, the skin and the accessory structures within the skin are all tightly connected to thermoregulation, as you'd imagine they would be. That's where you're coming in contact with the outer atmosphere, whether it's cold or warm. So three things there. First of all, we know about protection. Second of all, we've heard about sensory function. Third, about thermoregulation. And finally, and this one I've already made some notes in, is an interesting function of the integument that you might not immediately think about. And that is that your skin provides the mechanism for the production of vitamin D. Vitamin D is something that you don't get very much of naturally in your diet, and you do have to produce it yourself. Now, in the modern world, we actually have some foods that are fortified with vitamin D. So, for example, there are cereals and so on that are fortified with vitamin D. Or, you can go to a store and buy vitamin D capsules and take them orally that way. But that's a rather, new invention. If you just go back, 50, 60 years or slightly longer than that, there are many, many cases of people when they were not able to synthesize vitamin D for themselves that would get, a variety of maladies that are related to that. So I'm going to talk briefly about the integument's responsibility in making vitamin D. So this begins right in the epidermis of your skin. And so the stratum basal and the couple of layers of cells that are just above it are active still. Remember, their nuclei are producing keratin, yes, but they're also active at that time, quite living and quite active. And one of the things that they're doing is they are synthesizing vitamin D in the presence of UV radiation. So when you are exposed to sunlight, when your skin is exposed to sunlight, the UV radiation starts a process by which a product known as cholecalciferol, cholecalciferol is synthesized from a derivative of the steroid cholesterol. Okay, so we begin with this chemical called cholesterol. You learned about that back when you were learning about the biomolecules. It's one of the lipids. It's a steroid, and it's one of the base steroids upon which the body builds lots of other important molecules, including testosterone and estrogen. So cholesterol is very, very important. It provides flexibility in the skin. There's a whole bunch of reasons that cholesterol is so important to the body. But one of those things is cholesterol can be synthesized, or you can use that as a base to synthesize this very important molecule called cholecalciferol, which is kind of an early form of vitamin D. So cholecalciferol then is transformed in the liver to another molecule called calcidiol. Calcidiol, sorry, I'm having a hard time pronouncing it slowly. Calcidiol is the way you pronounce it quickly. And so this molecule then, having been converted from calciferol into calcidiol, is then converted to calcitriol in the kidneys. So notice the integument plays a big role in this process. The liver takes the byproduct produced in the integument and converts it to an intermediate called calcidiol, and then that is in turn converted into the final product called calcitriol. This is the active chemical form of vitamin D, and that's done in the kidneys. So these three pieces together, the integument, the liver, and the kidneys, finally performing the process of producing calcitriol, which is vitamin D. This vitamin D then is essential in the absorption of calcium and phosphorus from the digestive tract. So it's interesting, you can have a full meal filled with calcium, filled with phosphorus, and if you're not producing calcitriol, this vitamin D right here, you cannot absorb this out of the intestine, and therefore your body will be starving for calcium and starving for phosphorus, which is a really bad thing. And it has a major effect on the way your muscles perform, and has a massive effect on the way you produce healthy bones. And so these are really important products we need to be able to get out of our digestive tract, and we can only do it if we have vitamin D around. So very interesting. And of course, as you recall, if you can't get vitamin D and then you can't absorb calcium and phosphorus, you have these maladies that are the result. One of those is rickets. And rickets is a very painful condition that children often get, because as they're growing and their bones are forming, if they can't get the appropriate amount of calcium and phosphorus, they just cannot produce proper bones. And it makes their bones very weak, producing bow-leggedness, and that's just because the weight of their body is basically bending the bones into this bow-legged form, and it's very painful. And also people can get other kind of vitamin D deficiency problems, including osteomalacia. And that's a softening of the bones as you get older. So you really need to get the absorption of calcium and phosphorus in your diet all throughout your life. And that is perfectly related to the amount of vitamin D you can synthesize. Now, as I say, in present day society, vitamin D is added to a number of foods as a supplement, or you might just buy it specifically at the drugstore. But, the interesting thing is that if you could just expose your skin to enough UV radiation, you don't have a problem, because your body is perfectly capable of synthesizing vitamin D. We just don't get out very much anymore. Humans spend so much time indoors that we really don't get direct exposure of vitamin D on our skin. And, a high recommendation that most doctors will give people is if you are having issues and you're concerned about vitamin D and the synthesis of vitamin D, get out in the sun more. And it's difficult, living in a place where you don't have a lot of sun to do that. So when day lengths are very short, the farther north you go, or if you're in a place where there's a lot of cloud cover all the time, it's just hard to get that exposure. And so it's more common to have these maladies in those kind of areas. But if you can get the exposure, your body will synthesize vitamin D for you.